Imagine the universe for a moment. It's vast, isn't it? Full of mysteries, governed by forces we've studied for centuries, forces that shape galaxies and hold our feet to the ground. Now get this, scientists are buzzing with some truly electrifying news. Groundbreaking research has emerged, folks. It suggests that one of the most fundamental forces we know, gravity itself, might not be what we've always thought it was. This isn't just a minor adjustment in our cosmic manual. No, this could be a full-blown revolution, potentially rewriting our entire understanding of how the universe works at its deepest level. It's a genuine head-turner for the world of physics, making us all lean in a little closer. We all feel gravity's presence. It's that invisible yet undeniable pull that makes an apple fall from a tree, just as Newton observed. It's the cosmic glue that binds galaxies together into colossal structures, a silent conductor orchestrating the elegant ballet of planets as they pirouette around their stars. Sir Isaac Newton gave us the first comprehensive mathematical framework for it. Later, the brilliant Albert Einstein deepened our comprehension significantly, revealing gravity not as a force, but as the very curvature of space-time itself. It feels so constant, so utterly familiar in our daily lives, yet, despite its omnipresence, its most profound nature continues to harbor deep, tantalizing mysteries that scientists are still trying to unravel. But consider this possibility for a moment. What if gravity's true origin story lies hidden in an unexpected place? What if this colossal force, capable of shaping the cosmos, actually springs forth from the weird, almost magical rules of the quantum world? That's the subatomic realm, the domain of the incredibly tiny, where particles can exist in multiple states at once and pop in and out of existence. A place where our everyday intuition about how things behave often breaks down completely. Scientists are now seriously proposing that this inherent quantum weirdness isn't merely a curious sideshow in the grand theater of the universe. It might in fact be playing the leading role in the drama of gravity. This new idea is big, I mean truly big. It hints that the very force responsible for sculpting vast galaxies and dictating the motion of stars could be born from the most minuscule interactions imaginable, deep within the quantum foam. We're talking about a phenomenon known as quantum entanglement, a concept so bizarre and counterintuitive that even Albert Einstein famously described it as spooky action at a distance. Could this ghostly instantaneous connection between particles be the secret architect of gravity, the unseen hand shaping the cosmos? So, buckle up your cosmic seatbelts, everyone. We're about to embark on a thrilling dive into a profound cosmic mystery that possesses the potential to rewrite the fundamental rulebook of the universe as we know it. So, what exactly is this quantum entanglement that has physicists so captivated? Let's try to break it down into something more digestible. Imagine you have a pair of very special interconnected coins. These aren't ordinary coins, they are quantumly linked. If you flip one and it lands showing heads, you instantly know that the other coin, its entangled twin, has landed showing tails. This holds true even if that other coin is miles away or even light years away across the galaxy. You know its state without ever needing to look at it directly. Quantum particles, like electrons or photons, can behave in this astonishingly interconnected way. Their intrinsic properties, such as their spin or polarization, become inextricably linked. They cease to be independent entities and instead behave as parts of a single unified system, sharing a common destiny. This peculiar connection between entangled particles is not just strong, it's instantaneous. Or at least, it appears to be faster than the speed of light, which is supposed to be the ultimate speed limit in the universe. This is the aspect that Albert Einstein famously, and somewhat skeptically, dubbed spooky action at a distance. He found it deeply unsettling because it seemed to violate the principle of locality, the idea that an object is only directly influenced by its immediate surroundings. How could one particle instantaneously communicate its state to its partner across potentially vast cosmic distances? It's as if they share some kind of secret telepathic link that transcends our normal understanding of space and time. This isn't a flight of fancy from science fiction. It's a rigorously proven and repeatedly demonstrated aspect of quantum mechanics. Think about the profound implications of that for a moment. If you measure a specific property of one particle in an entangled pair, you instantly determine the corresponding property of its distant partner. This happens regardless of how far apart they have drifted from each other. They could be separated by the width of a laboratory bench, or they could be on opposite sides of a galaxy. It's not that one particle sends a signal to the other in any conventional sense. The phenomenon is far more profound and mysterious. It's as if, for these entangled particles, the concept of distance simply doesn't apply or carries a different meaning. They remain a single, unified entity, their fates intertwined, defying our everyday intuition about physical separation. This spookiness, this seemingly magical interconnectedness, has been experimentally verified countless times in laboratories all around the world. It's not just a theoretical quirk, it's a cornerstone of how the quantum world operates. And now some of the most forward-thinking physicists are posing an incredibly bold question. Could this very phenomenon of entanglement, this intimate quantum connection, be the underlying source of something as grand as gravity? Could the very fabric of spacetime, the stage upon which the cosmic drama unfolds, actually be woven from these invisible, entangled quantum threads? It's a truly mind-bending prospect, suggesting a deep link between the micro-world of quantum mechanics and the macro-world of gravity and cosmology. For many centuries, our primary understanding of gravity was masterfully shaped by the genius of Sir Isaac Newton. He envisioned gravity as a fundamental force of attraction, an invisible pull existing between any two objects that possess mass. The greater the mass of the objects, the stronger the gravitational pull between them. Conversely, the farther apart these objects were, the weaker this attractive force became. His elegant mathematical equations described the motion of falling apples with the same precision as they described the orbits of planets around the sun. These laws were so powerful and accurate that they successfully guided us on voyages to the moon. Newton brilliantly told us gravity worked, providing a magnificent descriptive framework. Then, in the early 20th century, Albert Einstein arrived on the scene and gifted us with an entirely new, revolutionary picture of gravity through his theory of general relativity. In Einstein's universe, gravity wasn't a force pulling objects through an empty passive space. Instead, he showed that mass and energy fundamentally dictate the geometry of spacetime itself. They tell spacetime how to curve and warp, and in a beautiful cosmic reciprocity, the curvature of spacetime, in turn, tells mass and energy how to move. It's a dynamic, intricate geometric dance. Planets orbit the sun not because they are being actively pulled by a mysterious force, but because they are simply following the natural contours, the curves in space-time created by the sun's immense mass. A truly magnificent and profound insight. Now fast forward to today, and enter the quantum challenger. This latest research, emerging from the cutting edge of theoretical physics, whispers something truly radical, something that could shake the foundations of our understanding. What if gravity, as so beautifully described by both Newton and Einstein, isn't actually a fundamental force or a fundamental property of spacetime in the way we've always assumed? What if, instead, gravity is a phenomenon? Much like how the sensation of temperature emerges from the collective, chaotic jiggling of countless individual atoms, or how wetness emerges from the interactions of water molecules. The new idea boldly suggests that gravity might actually emerge from the collective quantum behavior of entangled quantum bits or qubits, the fundamental units of quantum information that are thought to permeate the very fabric of spacetime. So, how might this proposed mechanism actually work? The theory posits that the density and the specific pattern of quantum entanglement within a given region of space directly determine the geometry of that space. Imagine a dense web of these entangled qubits. Where the entanglement is stronger or more concentrated in a particular area, this could manifest itself as what we perceive and measure to be a gravitational field. It's as if the spooky action at a distance that characterizes entanglement isn't just a curious feature confined to tiny, isolated particles anymore. Instead, it might be collectively and dynamically weaving the very fabric of spacetime itself, creating the dips, curves, and warps that Einstein so elegantly described with his equations. This represents a truly profound and potentially game-changing shift in our perspective on one of the universe's most fundamental interactions. If this radical and thought-provoking idea, that gravity arises from quantum entanglement, actually holds water and is confirmed by further evidence, the implications for physics and our understanding of the universe would be absolutely staggering. For many decades, physicists across the globe have relentlessly pursued a kind of holy grail, a theory of everything. This would be a single, unified theoretical framework capable of seamlessly uniting quantum mechanics, the incredibly successful science of the very small of particles and their interactions, with general relativity, our best theory of the very large, the science of gravity, spacetime, and cosmology. These two monumental theories are our most accurate descriptions of the universe, yet they notoriously clash and give conflicting predictions under extreme conditions, such as those found inside black holes or at the very moment of the Big Bang. Entanglement could potentially be the missing bridge, the crucial link that finally reconciles these two pillars of modern physics. This is precisely why scientists, researchers, and cosmologists are practically vibrating with excitement and anticipation. Forging a definitive connection between gravity and quantum entanglement could unlock some of the universe's most profound and stubbornly persistent secrets. Consider the enigma of dark matter, that invisible, mysterious substance that seems to outweigh all the normal visible matter in the cosmos by a factor of 5 or 6. Or what about dark energy, that even more baffling force that appears to be causing the expansion of the universe to accelerate over time? Could an understanding of gravity rooted in entanglement provide us with new, crucial clues or perhaps even definitive answers to these cosmic puzzles? It opens up entirely new avenues for theoretical research and experimental investigation, allowing us to think about the cosmos, its intricate structure, its origins, and its ultimate fate in completely novel ways. However, we must approach this with a healthy dose of scientific caution and remember that this is still cutting-edge, frontier research. It's a bold, compelling hypothesis, but it is still in its early stages of development. A great deal more theoretical work, mathematical modeling, and, crucially, experimental evidence will be needed to rigorously test this idea, to see if it can truly stand up to the intense scrutiny of the scientific method. Science, after all, progresses by constantly challenging established ideas, by rigorously questioning assumptions, and by bravely exploring new, often unconventional possibilities, even if they seem strange or counterintuitive at first glance. The universe, as I often say, is under no obligation whatsoever to make sense to us. It's simply, and we, as inherently curious humans, must continue our relentless quest to understand its intricate ways. So, what do you think about this potentially cosmic revelation? Could the spooky, almost ethereal quantum world, with its entangled particles, really be the hidden puppeteer pulling the strings behind gravity, the grand force that meticulously shapes our entire universe? Does this mind-bending idea expand your own cosmic perspective or perhaps blow your mind a little? We genuinely want to hear your thoughts, your insightful questions, and your cosmic ponderings. Please share them with us in the comments section below. The universe is an incredibly vast and wondrous place. Let's continue to explore its mysteries together. Thank you for joining us on this fascinating journey into the frontiers of science. And hey, if you enjoyed this glimpse into the cosmos and the strange world of quantum gravity, don't forget to like this content, comment with your insights, and subscribe for more mind-expanding adventures.